You're welcome, our dear student, in this new episode from your program Madrasa al How. Today we're gonna talk about lesson 3 in unit 1. Today we're gonna talk about atomic structure. Atomic structure. As we said last time, that matter, as you see with me, matter consists of molecules. Okay? And the molecule is the smallest part of matter that can be existed freely. But molecule consists of smaller particles that are called atoms. Atoms. Today we're going to talk about the atomic structure, the structure of atom. As you see with me on this monitor, atomic structure. What's meant by atom? The atom, it is the fundamental building unit of matter. What's meant by fundamental? Fundamental is the basic one. That means it can't be divided. No cut. It comes from the word in Latin, no cut. So the atom, it is the fundamental building unit of matter, and it can't be existed freely. It's not like the molecule. Molecule can be existed freely, while atom can't be existed freely. And the chemical symbol, let's now talk about the chemical symbols of some elements. As you see, my dear student, this is the atom. Inside the atom there is nucleus, and around the nucleus there are some electrons that revolve with high speed. Okay? Symbols of elements. Each element is symbolized by some letters, maybe one letter, maybe two letters. Okay? As hydrogen, hydrogen is symbolized by H. And as you see, my dear student, H is capital. H is not small letter, but it is capital letter, as you see on the monitor, please. Number 1, hydrogen, H. Number 2, helium. Helium is symbolized by He. And as you see, my dear student, H is capital, E is small, because if the symbol of any element is symbolized or or composed of two letters, the first one must be capital letter and the second must be small letter. Third one, lithium, L capital, I small. Then carbon, C capital. Nitrogen, N capital. Neon, N capital, E small. Magnesium, M capital, G small. If you write it M capital, G capital, it's wrong. M capital, G small. Aluminium or aluminum, American and British language. Aluminium, A capital, L small. Sulfur, S capital. Silicon, S capital, I small. Phosphorus, P capital. Chlorine, C capital, L small. Potassium, K, because it's not P here. Calcium, Ca, C capital, A small. Okay. Potassium, K, it's not P, but it's K. Why? Because it's from the Latin word calcium. Calcium, C capital, A small. Iodine, I. Gold, A, U, because it's not in English word, but it comes from Latin word. Silver, Ag, from Latin word. Copper, Cu. Lead, P capital, B small. Boron, B capital. Beryllium, B capital, E small. Argon, A capital, R small. Chromium, C capital, R small. Bromine, B capital, R small. Iron, Fe, from the word ferrum in Latin. So, Fe, the first two letters from the Latin word that equals iron in English, but in Latin ferrum, so it will be F capital E small. Not F. F only means fluorine, but Fe means iron. Sodium, from the word natrium, so it will be N capital A small. But the atom consists of what? Of nucleus and energy levels, or nucleus and electrons. But now, what's meant by nucleus? As you see, my dear student, on this paper, this is the nucleus. It is the core inside the nucleus, inside the atom, and it includes what? It includes positive particles, positive, very small positive particles, that is measured in angstrom unit. Angstrom, just 1 angstrom equal 1 times 10 power negative 10 meter. It's called protons. And this proton is positively charged particle. It is positive and symbolized by the addition or the plus symbol. And another particle that has no charge, it is neutral. It is neutral, so it's called neutrons. So protons and neutrons exist in the nucleus. Protons are heavy relatively to what? To electrons. Neutrons are heavy relative to electrons. So protons and the neutrons are heavy. They give the atom its mass. So it is called the number that gives the atom its mass, so it is called mass number. Mass number. So now what's meant by mass number? It is number of protons plus number of neutrons. This is called what? The nucleus. Number 2, electrons. Electrons are negative charged particles that revolve around the nucleus at very high speed. So you imagine that there are some circles around the nucleus, but in fact there are no circles. But there are electrons that revolve with high speed around the nucleus. These electrons have negative charge and their mass is so small. Okay, now let's return back again to the monitor. Atom consists of nucleus and electrons. First, nucleus, it is the central core of the atom. It is positively charged. Why? Why it is positively charged? Because it contains 2 types of particles. Number 1, protons. They are positively charged particles. Number 2, neutrons, electrically neutral particles. That means they have no charge, not positive, not negative. Now the question is, give reason for the mass of the atom is concentrated in its nucleus. Why? As I told you, my dear student, that because it contains protons and the neutrons that have more mass. Because electrons has negligible, that means we can't put it in consideration, متجاهل, mass relative to mass of the proton or neutrons. Okay. Second, electrons. Number 1, nucleus. Number 2, electrons. What's meant by electrons? They are negatively charged particles that revolve around the nucleus at very high speed. And the properties of electrons, number 1, they have very small mass, negligible mass. Number 2, they have negative charge. Number 3, they revolve around the nucleus at very high speed. Now, what's meant by mass number? As I told you, my dear student, mass number means the number, the sum or summation of the particles inside the nucleus that have more mass. What are they? Yes, they are protons and or plus neutrons. Mass number, it is the sum of the number of protons and neutrons in the nucleus of atom. But now, why are the elements different? Each one is different from the other one. We have 118 elements, the known number of elements as we studied before in primary 4, 118 elements. What's the difference between them? Why oxygen is oxygen and it's not nitrogen? Why iron is iron and it's not gold? What's the difference? The difference is just in the number of protons. If the number of protons is 1, so it is hydrogen. If the number of protons are 2, so it will be helium. If the number of protons are 3, it will be lithium. If the number of protons may be 8, it will be oxygen. If it is 11, sodium. 26, it's iron, and so on. 29, it is copper. Okay? See you. So, the difference is just concentrated in the number of protons. So, how can I know that this atom is atom of iron? If the number of protons inside its nucleus is 26. So 26 is the number that makes me sure that this atom is the atom of iron. So it is called the atomic number. Atomic number. What's meant by atomic number? It is the number of protons inside the nucleus. It is the number of protons inside the nucleus. Atomic number, as you see, my dear student in the monitor, it is the number of protons in the nucleus of an atom. But as you see on this diagram, this is the nucleus that contains red and blue shades, red and blue particles. The red particles represent what? Protons, yes, positive charges. And the blue ones represent neutrons that are neutral. And out the nucleus, there are electrons that revolve around the nucleus. Give reason for the atom is electrically neutral. The atom is electrically neutral. As you know, my dear student, positive is electricity, negative is electric charges. So, if I have 10 positive, okay, and 10 negative, that means I will get 0. So negative cancel positive or positive cancel negative. So they cancel each other, so the charge, the whole charge equals 0. It's not charged at all. So if atom contains 10 protons and negative 10 electrons, that means it is not charged. As atom, not nucleus. Nucleus has positive charge, but as its atom has neutral. It is neutral. It's not charged. Why? Give reason. Because number of positive protons equal number of negative electrons. If it is an atom, it means that the positive protons equal negative electrons. So it is electrically neutral if it is atom. But if the electrons are less than protons, it's not atom. If electrons more than protons, it's not atom. It's called ion. But atom, if it is atom, it means it is electrically neutral. Give reason. The atom is electrically neutral because the protons, number of protons equal number of electrons. As you see with me, my dear student, because number of protons equal number of electrons. On the monitor, please. Okay. Now, some notes. Number one, hydrogen atom is the only atom that doesn't have neutrons. No neutrons. So, its mass number equal atomic number. May I have attention, please? If, sodium contains positive 11, okay, and neutrons 12. Okay, what's the number of electrons? If it contains positive 11, so number of electrons, yes, negative 11. Give reason, because number of positive protons equal number of negative electrons if it is an atom. So what's meant by the atomic number here? What's atomic number? Atomic number is 11, because atomic number means number of positive protons or negative electrons in the atom. So atomic number is 11. And what's mass number? Mass number is the sum of number of protons plus number of neutrons. So it will be what? 23. Usually, almost the mass number is more than atomic number, because mass number means number of protons plus number of neutrons, while atomic number means number of protons only. But in only one case, if it is hydrogen, the only atom that contains 1 protons and 0 neutrons. So atomic number here is 1. Atomic number is 1. And mass number is what? Is 1, atomic number or number of protons, plus 0, number of neutrons, so it will be 1. This is the only case that mass number equal atomic number, if it is hydrogen atom. So give reason for hydrogen atom is the atomic number of hydrogen and the mass number are equal because it has no neutrons. It is the only element, the only atom that has no neutrons, and its mass number equal atomic number. Okay. Number 2, the atomic size is very small. On the monitor, please. So it is measured in angstrom unit. 1 angstrom equal 1 times 10 power negative 10 meter. So small. So small. Okay. The energy level. What's meant by energy level? Energy levels are imaginary regions or imaginary places around the nucleus in which the electrons move according to their energies, which are calculated by the relation of 2n squared. They are imaginary regions or places around what? Around the nucleus, in which the electrons move according to their energies. And energies they are K, it's number 1, L, number 2, M, energy level number 3, N, energy level number 4, O, number 5, P, number 6, Q, number 7. Look at me, my dear students. K, it's number 1, L, M, N, O, P, Q. Are all of these energy levels exist in all the 118 elements? No. Hydrogen had just 1 energy level, K. Hydrogen has only K. Helium, K. Lithium, K and L, and so on. But the heaviest atom Heaviest atom includes the 7 energy levels, K, L, M, N, O, P, Q. And the least one, the lighter one, which is called hydrogen, just contain what? 1 energy level. Okay? So the elements, the atoms, are differ from each other in number of what? Number of energy levels. But these energy levels are imaginary places because they represent the path of electrons around the nucleus. The electron move with high speed, so you imagine that there are just some circles, imaginary places, okay? Okay, but now let's talk about the relation. K can carry just 2 electrons at most. L can carry 8. M can carry 18. N can carry 32. O can carry 32. P can carry 18. And what's meant by quantum? Now, quantum, it is the amount of energy lost or gained by an electron when it transfers from one energy level to another. What does it mean? It means that the energy level in K has the least what? The least energy. But if it gains energy, it can transfer to L. But what is the amount of energy that it needs to transfer to the higher one? It needs quantity that is called quantum. Quantum. And also it means if an electron in the 3rd energy level, M, if it lost a quantity of of energy, and lose it, it can transfer to the lower one. What is this amount? It's called the quantum. So what's meant by quantum? Quantum is the amount of energy that the electron gain or lost to transfer to energy from one energy level to another one. What's meant by excited atom? It is the atom that gains a quantum of energy. Not lose, but gains. If the atom gained quantum of energy, it is called the excited atom. Now, the electronic configuration, I can calculate the number of electrons that saturate one energy level, any energy level, from the relation 2n squared. But what's n? It is the number of energy level. What does it mean? If number 1, how many electrons are in K? In K, it's number 1, so it is controlled by the relation 2n squared. 2 times what's n? 1 squared, so it will be 2. And so on. 2 for L, 2n squared, 2. L is number 2, 2 squared, 4 times 2, it will be 8. And M, it's number 3, it's controlled by 2n squared, 2 times 3, and here is 3 because it is the 3rd one, it will be 18, and so on. As you see, my dear student, K, number 1, 2 by 1 power 2, it will be 2 electrons. L, number 2, controlled by 2n squared, 2 by 2 squared, it will be 8. Number 3 is M, 2 by 3 squared, equal 18, and number 4 can carry 32. But this relation is not applied on the energy levels more than 4th one, because if the 5th one here controlled by this relation, it will be 2n squared. This is number 5. Number 5, it will be 2 times 5 squared, it will be 50. But it's not in fact, because if any energy level carries more than 32, it will be unstable, and this atom will be decomposed and will be no more. Okay. My dear student, as you see, this is the last give reason today. The relation 2n square is not applied to the energy levels higher than 4 because the atom becomes unstable if the level contains more than 32 electrons. Now I have to say thank you and see you next week.